Tonight, we're gonna play a game. Yes. Did anyone else ever play the Bob game during swimming lessons? Yes. One person, excellent. So for the rest of us, the Bob game is where your swimming instructor told a story about a guy named Bob. And every time they said Bob, you'd have to bob your head under the water. And the game we're gonna play is like that. I'm gonna tell you a story, and you're gonna have certain actions you have to do when I say certain words. Now, I always hated the Bob game. Absolutely hated it. Didn't want to put my head under the water. But luckily for you, we have no water. Instead, what you're gonna have to do is high five every time I say cam, C-A-M, and hiss every time I say acid. So high five on cam, hiss on acid. You have a second to pick your high five buddy. This is your buddy for the evening. You're high fiving them all evening. Okay, excellent. Like you're practicing. We're gonna practice actually. Ready? Cam, cam, acid. Cam, cam, acid. Cam, cam, acid. Okay, you're ready. Some of it is gonna be that fast, so keep your ears open. It's 2011, and I'm sitting in a course on plant anatomy with my lab partner during our undergrad. Each pair in the course is being assigned a plant to dissect and study and learn as much as we can about its internal makeup. My partner and I get a CAM plant. Good. CAM stands for Crassulacean acid metabolism and is found in desert plants like cacti and succulents. One day we use a stain on the leaves that's supposed to turn proteins red, or supposed to turn proteins black. But when we look at our stain section under the microscope, nothing's black, half of it's red. This is weird, we're confused. We ask our professor, who says he doesn't know, and I realize now he was probably lying to us. But then it took us till the end of the semester to figure out it has to do with the A in CAM, the acid. One of the coolest things about plants in hot, dry desert environments is the different advantageous adaptations they have to deal with the harsh climates, like Crassulacean acid metabolism. CAM plants have an extraordinary relationship with their stomata, which are like holes in plants that allow for gas exchange. And stomata are present on CAM plants as well as all non-submerged vascular plants, which is most plants. And they need that gas exchange because plants need to get rid, you're very enthusiastic, need to get rid of oxygen gas, absorb carbon dioxide gas, and get rid of and absorb water vapor. And stomata can actually open and close. And in most plants, stomata are closed at nighttime and open up during the day. But CAM plants switch it up. For CAM plants, in the hot, hot heat of the desert during the day, the stomata are closed. And then at night when it cools down, then they open up and gas exchange can take place. But this creates a problem for our CAM plants though, a frustrating photosynthetic foible, a corrosive conundrum. In order for photosynthesis to work, it needs carbon dioxide gas and light energy from the sun to close their stomata during the day and still be able to photosynthesize. CAM plants have split their metabolic pathways into two distinct parts. At nighttime, the stomata are open, the plant absorbs carbon dioxide gas and converts it into malic acid, which is then stored in cell storage organelles called vacuoles. Then when the sun rises and the plant receives that light energy from the sun, it converts that malic acid and uses it in the biochemical cycles of photosynthesis to produce the sugars that growing CAM plants need. The A in CAM, the acid, comes from the production of this malic acid and subsequent rise and fluctuation in the acid levels in the plant. Through the night, CAM plants produce so much malic acid it actually fills up the vacuoles and has to be stored in the cell cytoplasm, the jelly-like fluid inside of cells. And this causes the acid levels of the cytoplasm to rise and actually impacts how CAM plants taste. Though the CAM pathway was only discovered in the 1960s, people have noticed for centuries how much more acidic cacti taste in the morning compared to the afternoon. So to deal with our CAM plant messing with our research and making it impossible to use certain stains to determine things like protein content of the leaves, my lab partner and I had to adapt. We built our final research presentation as a story, using humor to communicate with our class our frustrations, confusions, and triumphs. And you have all triumphed here tonight, hissing and high-fiving like champions, learning all about how CAM plants use acid to survive. So go forth, and just as CAM plants do every day, and you did here tonight, adapt, survive, and remember, CAM, acid! Thank you.